Link is in the syllabus, right?
The link is on the page, the web page.
Oh.
Yeah.
I'm here from Mass Site.
Oh, we're good. We actually went there already.
Oh, you already did?
Yeah.
Okay.
I keep forgetting to remind. I told Kathleen a while back, and we always do. So that's my bad. I'm sorry you had to come out.
Don't worry about it.
All right. So I was like a minute late to class, and there was somebody already in here talking to my other class, and we had already done the whole field trip like we did, right? I was like, oh shit, so I had to wait it out. I'm like, all right, why did they send them here? We already went there. All right. Sorry if you're from the tutoring center. Nothing against you, but we already did it. So let's get back into chapter 7. We did a very little bit of it last time, and the main reason I wanted to show you something before I let you go is to make you really realize how important factoring is. I mean, I can say it and I can say it, but until you see it, you're like, oh shit, the whole chapter is about factoring. I got to know factoring. So let me start off with something kind of nice here. Oh, let's see. So this is where you got to be really careful, because you can't. Division cannot cancel addition. Obviously, right? Division is not the opposite of addition, is it? So what that breaks down to is I can't break into an addition problem. So what do I really have to do first on this kind of problem?
Is it factor out a common multiple?
Yeah, good. Factor whatever way. So in this case, the only way I could factor on both of these is GCF, right? So you have to factor first. And remember, last time I showed you, if I just had, let's say, 8 over 16, well, that's a little too easy. Screw. If I had, no, that's fine. 8 over 16. How does that reduce? Yeah, why? Because 8 is 8 times 1. 16 is 8 times 2. This is the step that we don't normally do, right? We don't have to, because they're just numbers and our brain normally latches onto those easier. But that's really what we're doing, and since division cancels multiplication, those go away. So here I just have to do it more explicitly. These aren't numbers now. These are variable expressions that represent numbers. So how do you factor the top?
6 times. Oh, wait a minute.
A 2 comes out.
3, 3.
I haven't done it, but could you, in that way, in that sense that you did it, can you factor, oh, not factor, well, I guess so, like 6 times 1 times t plus 4 times 2, and divide by, you know.
But then is this number factored? So if I said factor 18, and you say, okay, it's 12 plus 6, which is 4 times 3 plus 2 times, is that factoring? Why is that not factoring? Because of that addition. So it's not factored if there's an addition between your parts. But if I take a 2 out, what's in between 2 and this? Multiplication, right? Cool. Now the division can do its job, because I got its opposite.
Well, when you do that, like, you know, like 2 times, or 6 times 1 times t, and then underneath that, 6 times 2 times t. And then you're, I mean, would you end up with the same answer?
Maybe, if you did it. So if you had 6 times 1 times t,
Right.
you still got plus 8, so I'm not
Right.
sure what you're going to do with that.
Well, I mean,
Over
4
12,
times 2.
6 times 2,
Because
sure.
it's a common multiple.
Sure.
Yeah.
4 times 2.
And then
Over 6 times 2 times t.
Plus 4 times 4.
Kick ass, you still got addition in the way, so you can't divide
But what
anything.
about?
You can't divide anything because you still have addition in the way. Do you see that?
Alright.
Yeah.
Cool.
So it's really, if I have, can I reduce 8 over 5?
Well,
No.
you can, but no.
Can I reduce it?
Oh, no.
I didn't say rewrite it. I
Put it in
can,
an improper fraction.
but can I reduce it?
No.
I love you guys. You're like, I don't like your question. Let me answer your question. But even though I can do this, I don't care that I can do that.
Right.
I don't care that I can do that. I don't care if you write this as 5 times 1 or something. I can't suddenly all of a sudden do that and say 8 divided by 5 is 3. Or if you say this in 1 4 or something, it's like, whoa. Okay. But I'm not blaming you too much because we're not used to working with variable expressions. So our brain tries to latch onto the parts that look familiar. But I can't do a number plus a number and cancel something, and that's what this is. This is an unknown number, so I can't do that. So I have to factor first. Because then the parts, of course, what comes out of the bottom? 4.
3t plus 4.
So what cancels exactly?
3t plus
Yeah, the 3t's plus 4's, and
1/2.
yeah, that becomes 1/2. So the answer is 1/2. Kick ass. Now, real quick.
Well, real quickly. I mean, that just because it was a nice problem, but I mean, already 16, over 12t, that's already 1/2 because it's common variable. And
But then what do you do with his other 1/2?
Yeah, sure, yeah.
And how does that make 1/2? You see?
Right.
So you got to be real careful. I mean, there's yeah. Now watch this. Watch. What's t? Is t something specific?
Any variable?
Yeah, any number I want it to be, except anything that makes the bottom 0, right? So let's let t be. Pick a number.
3.
Okay, good. I can work with 3. You guys, stay with me now. This problem is done. I'm about to do weird side shit that I sometimes do. I want to show you what happens. So if t is 3, what is this?
That's 18.
18 plus 8 over
36.
36 plus 16. What's 18 plus 8? And what's 36 plus 16?
It's 50.
And this reduces to
1/2.
1/2. Of course, I look at that and I think cards. I don't know if anybody else does. 52 cards, 26 are black, 26 are red.
You gamble too much.
I don't gamble at all. Because I know the odds way too well.
So really, like, I mean, when you get, what would the technique be? Just counting cards or something like that? Or like,
Oh, let's not go there right
you
now.
can make a video of that and I'll watch
This
it.
is not that 21 movie where the teacher teaches them how to cheat.
Oh, that Breaking Bad?
Yeah, don't
You can
get
do
your
that?
hopes up for
The
me.
math edition of that?
Alright, but all I want to show you is no matter what I make t, it shouldn't matter what I make t as long as that doesn't make the bottom 0. What we just did here is prove it's always going to become 1/2. You guys kind of with me? Alright, so all I can do to make this problem a little bit harder is to put harder things to factor, but the idea doesn't change. It says factor, factor, kill. Right? And I teach very violent math. So here's one. Let's try another one. It's a little more interesting. You guys try this one. We'll always try to force that top thing to do things it can't do. It's 2 terms, it's not squares or cubes, so what do you always try first? What do you always try first when you're factoring? What do we do up there?
Find the common.
Yeah, you always try GCF first. Because either it's the only thing you can do, or it makes it easier to do. Right? So that'll save your ass. I mean, if you try to do this like this, oh no, it's not going to work. What comes out of these though?
X.
X. And what's left?
X minus 3.
X minus 3.
Yeah, difference of squares, right? So x plus 3, x minus 3, or either way, who cares how you put that, right? Now what cancels?
X minus 3.
Good, now I can cancel because division can cancel that multiplication out, right? And then what's the answer then? Kick ass.
So, because I tend to get confused, like let's say if that was a trinomial, and if you say you didn't happen to cancel out, you're just kind of just trying to simplify, and by doing that, factoring, I get confused between which one's an x and minus and which is addition. Like on the trinomial, you taught us like I think the end number you're trying to multiply those two, and then the middle
Yeah,
term
okay,
you're
so
trying
let's
to
do an example like that. And I can do the same thing we did on this one, right? I can let x be some number. What could x not be?
0.
X could be 0 all day long, right?
3 or negative 3.
It can't be 3 or negative 3 because that would make the bottom 0. Cool. So let's try one with trinomial in it and a cubic in it. So you guys do this one. most common mistake is people will come in and say, oh, 2x's cancel, yay, and 27 and 15 reduce. Right? But why you can't do that because you can't break into a subtraction addition problem. Division can't do that. It's not what it's made to do. So what do you get on the top here?
X minus 3.
Yeah, catch up to this. So yeah, x, 3, 3, 3. So x minus 3 and the little tiny dude.
And then x squared plus 3x.
Good. So opposite
Right,
sign.
and then
Product.
plus 9.
Good. And then the other two 3's, you pass, right? Same, opposite, always positive. So, remember that? It's a good little thing to keep it straight. Over.
Oh, that's a minus 8.
X plus
Minus 5.
Yeah,
So
minus
you got to be
5.
minus 5 so that it comes out to be
Yeah,
positive,
I wrote it wrong.
and that adds to be negative 8, right?
Got it.
So then what can cancel?
The x
X
minus
minus
3.
3.
So then this is your answer. Right? So,
And
and
always
that,
keep the parentheses, right?
it doesn't matter. The only reason they're there right now is because they're mean multiplication between this and this, and once I kill that, I can take the parentheses off. Doesn't really matter. Cool. So again, like I said, the more you know factoring, the easier this is. The less you know factoring, the more impossible this gets. Right? Now watch this. Let's take one step up. And you're all like, no, let's take no steps up, Janice. Remind me, so this is something from way back when. How would you do this? What do you got, John? 30. Well, I like it. Yeah. Now I still have some people that would just go ahead and say 28 times 13 and 39 times 14, get these big ass numbers, and then, my God, I won't even think about trying to reduce that. So much easier to reduce when they're smaller, right? So how could I do that? Can I reduce between these two?
cross multiple.
I can reduce. It's not cross multiplication, right? It's cross reducing. Because multiplication can cancel division, so if it's top and bottom, I can reduce. So 14 goes into 28 2 times. 13 goes into 39 3 times. So then what's the answer? 2/3. Kick ass, right? And again, behind the scenes is, this is 14 times 2, so the 14 canceled and the 2 is still there, right? So you can break each number apart. So when I get something more complicated that's a variable expression, so if I had something like this here, let's see, Jeff, if you can think ahead enough. Yeah, you got it. Ooh, that's gross and yummy at the same time. So, I mean, this is actually a whole another section in the book. So, this is actually from section 7.2. But what I desperately want you to realize is they didn't have to make it another section, right? What's different here? Nothing. I still factor everything. I still cancel. If it's on the top and the bottom, I can cancel it. So those two sections are the same thing. If you believe it. It's true. If you're pulling your hair out trying to factor this, it's because you haven't factored this yet. If you ever see a cubic dude in one of these problems and there's a trinomial, leave the trinomial and do him first, because this might be the big dude from him. And it is. In the big dude, you can never factor, right? So you could go insane if you try to factor it. It's not going to work. It's not going to go anywhere. How do you factor the top?
X squared minus 2.
Careful.
Oh, 2x. No, wait.
If you take an X out,
Yeah, my bad. Minus 4.
I like it. And then this guy, yeah, good. 1x minus 1, 4. The other 2 x's.
Plus 4x. Plus
Good.
16.
And then the other 2 4s. So see, that's the same thing now, right? So look out. If you see a cubic part of these problems, do that first, believe it or not. Because then you'll see if another trinomial, you don't have to waste time on it, then you just kill the whole damn thing. So you die. And on the bottom you get x cubed.
So those 2
That was
can
creepy.
cancel out right there. Since if you cross multiply, do you have to continue to cross multiply since you can find?
No. So I didn't cross multiply anywhere here, right?
Oh, cross. Yeah, I'm sorry. Cross reduce.
Cross reduce. It doesn't matter. You can do up and down, cross, and whatever. As long as one of them's down and one of them's up, they can cancel. Yeah.
I'm having problems with that x to the third power of minus 64.
Oh, here.
A quick way to factor, I just get confused.
All right. So we did a problem like that earlier, but just to remind you, it's 2 terms. There's no GCF, so the only things it could be are squares and cubes. And if you look at the 64, you might think it's squares, because 64 is 8 times 8. But that tells you right there, it's got to be cubes. So 64 is 4 times 4 times 4. So if you notice, it's 2 terms. It can only be squares or cubes. It's got to be cubes, so now you think break everything up into 3 parts. Right? So this would be x times x times x. This is 4 times 4 times 4.
Okay.
Little dude, big dude. 1 of each, little dude. 2 of each, big dude. 1 of each, 2 of each, product in the
Oh
middle.
my god, it's so easy.
All right. But it's just a process you just got to remember. That's why people don't like it, but actually if you remember it, it's the easiest form. But we don't like it because it's hard to remember for some of us. And the other ones we can actually work on it. We can sink our teeth into it, right? 2 numbers that multiply with this and add to be that. I can make lists. I can do stuff. This is, you just got to know where things go. You just got to know where things go. All right, so that's how we got there. And what else cancels?
The x minus 4.
And one last thing.
The x's.
Yeah, 1x cancels and leaving you with how many here?
2.
All right, so what's the answer?
1 over 2 x squared.
Beautiful. The answer is not x squared, it's 1 over x squared because those are on the bottom.
Would it be x to the minus 2?
Okay, but in general, you don't stop here. You always write your answer with positive powers. So it's just convention to leave your answer with positive exponents. Just keep it positive, exactly. Whenever you can. All right, how's that? Now, here's the here's the last level on these, and this isn't even a whole other level. It's not a whole other level. That's an old Mad TV reference. Sorry. If that problem would have started off like this, what would have been the first step? Multiply by the reciprocal, right? So we would say this is 28 over 9 times 13 over 14. 39, sorry. And then we would have done it the same way, right? So if this would have been divided by that, we would have first multiplied by that. See how division is not different. It's multiplication. It's just one. First step, reciprocate. Next step, factor. Last step, kill. Right? So if there's a division sign in there, just don't forget to flip.
And then multiply.
That was freaky sound. Sorry. I would easily just... What is that?
What? Oh, this?
Oh, that's God, that sounds so weird. Let's see. Is there anything freaky in here? Oh, here's a little something. Let's see what you guys think on this. right?
Oh, is that 2y or 24?
2y.
Oh.
So yeah, what comes out of the top? 2. What's kind of wrong about what's left? Are these the same? No. If they're not the same, you cannot cancel them. But they want to be the same. Do you see what I mean? What are they offset by? Yeah, here y is positive, there it's negative. Here x is negative, here it's positive. So if I took out a negative 1, so if I would have just taken out a negative 2 in the first place, these would have changed signs. You guys see that? So if I take out a negative 2, now the x was negative, it's now positive. The y was positive, now it's negative. So now I can cancel those. Right?
So it just depends what you factor out.
Exactly. So what you do is you do the problem like you always would, because you never know when this is going to show up, but if you end up with one piece that's almost the other piece just turned around like that across a minus sign, just take a negative out of one of them. Don't take it out of both of them, because then they kind of like pass each other by. Just take a negative out of one of them, and then they can die. They want to die. That's horrible. Terrible. This is a rough life being a variable. Please end it. Oh, that's horrible, Jeff. All right, it's fine. I didn't mean to go there. I never really analyzed my vicious way of doing math too much. I don't want to. All right. Yeah, that's it. The only thing they can do now is just, load it down with more and more stuff in it to make the factoring hard. But what's most important for you guys is what's the process? Factor, 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 kill, kill, kill. Right? Okay. Let's see. All right, so let's focus on this for a while, because this is an interesting idea. So that was section 7.1 and 7.2. And just to remind you guys, there was one other thing in section 7.1. We talked about it last time, and it's actually come up a couple times today. If I ask you... let me make sure. Let me ask you the same way they do. Okay. List all numbers that make the following undefined. That's how they say it in the homework. List all numbers that make the following undefined. So we know what undefined means. What does undefined mean?
0 on the denominator?
There you go. But if the bottom is 0, that's undefined. I can't do that. It's not defined on how to do it. So then how do I set that up mathematically? What's the bottom? What's the bottom? Yeah, okay, you're getting ahead of me. The bottom is 3x plus 7. And I want to set that equal to 0 to figure out what it can't be. Now, remember I taught you to do this? The problem kind of says list the numbers, but I mean, to me, it almost feels weird to put equal, because we just said it can't be 0, right? So in general, I just like to put, 3x plus 7 just can't be 0. That's all there is to it. That's what that says, right? The bottom can't be 0. And then how do you solve that?
Minus 7.
Subtract 7.
Divide by 3.
Divided by 3. So x can't be negative 7/3. So that works for me. That's related to the domain of this. Domain is all the x values you're allowed to use. So you just can't use that one. You could use anything else you want. So of course that was easy because the bottom was already
Oh, that's it, we're done?
factored. Yeah, that's
okay.
it. Why do I not care about the top?
Because that doesn't...
Is there anything the top can't be? No, it could be 0. 0 divided by something is just 0, right? Cool. So it's just the bottom that would freak it out. So if it started like this instead, what you got, Jeff? I'm trying to make one out. Ooh, that's really yummy. All right. I like that problem. And make sure it's right. Yes. So we don't like cubes, but then we sometimes forget about this guy, which is like the second least favorite factoring form. Just make sure everybody's going in the right direction. Because some of us aren't going anywhere. What's the first step? To factor the bottom? Yeah, and why am I trying to factor the bottom? Why was this easy? Because I could see the parts of the bottom. Just have one part. Well, how many parts are there hidden in here? There's 2 parts. I got to figure out what they are, and then we can do the same thing we did there. So 6 times 7. So I need 2 numbers that multiply to be 42 and add to be 17. Now watch. If you having any trouble, watch this. Give me 2 numbers that add to be 17. It's easier to do that. 10 and 7. What's 10 times 7? Shit, I need to be 42. So not 10 and 7. What about 9 and 8? What's 9 times 8? Now watch. So we did 10 and 7, but that makes 70. No good. What's 9 times 8? 70. Oh shit, we're going the wrong direction. So instead of going 10 now, let's go 12 and 5. What's 12 times 5?
60.
Oh, we're getting closer.
14 and 3.
Yeah, 14 and 3. There you go.
So, okay.
I think I've said this before, but I don't know why when we teach this, we seem to make it sound like you have to find the factors first. But who cares? You just need 2 numbers that add to be 17 and also happen to multiply to be 42. Who cares which one you make them do first? So it's so much easier very often to make this true and then check to see if that's true. Yeah?
So then the bottom, there would be no need to factor that, because if you were to drop the 6, let's say, if it was x squared plus 17x plus 7, there would be no need to factor it because you can't, it's already done.
Yeah, you can't factor that.
Okay,
So
but there's a coefficient higher than 1.
Well, no, you couldn't factor this just because there's no factors of 7 that make 17, right? That's the only reason. Right.
That's like kind of the general thing, kind of?
No, don't try to generalize too much.
Okay.
It's just because in this case, I can't find factors of this to add to be this.
So you just multiply that.
No. Now, one thing you can generalize is, why did we do this? Because there's a number that's not 1 here. So you always multiply that by that.
Okay.
Okay. So how do I factor this now?
So x plus 2, no, okay.
6x, 14x.
Good. So now you use these numbers. The numbers you have plus 14x, plus 3x, plus 7. Right? Now you can group it. So I have seen several people successfully do this on the homework, so this is good. So how do you group this?
2x plus 1 times 2.
Yeah, 2x. And what's left in there? And what's the only thing I can take out of 3x plus 7? Good. Nothing really, so just 1. And if you do that, it makes it look a little bit better. What's the last step now? Yeah, 2x plus 1, 3x plus 7. And now that I've got that factored, what do I do with that to answer the question?
Set it equal to 0.
Yeah. Set it equal or set it not equal to 0, right?
Can you
So-
rewind back and do that from, I'm just having trouble keeping up. So you multiply that.
So you're cool after this step here, right?
Yeah.
So then these 2 you use to rewrite the middle term. Because what is 14x plus 3x?
17.
Yeah. So, but those 2 numbers are the ones that'll make the grouping work. So then you just group it. You see what comes out of the first 2?
There we go.
What comes out of the last 2? Just a 1? Yeah. And now I take that. And how do I do this? Set it not equal to 0. How do I solve that? Yeah, exactly. What's the only way a product can be 0 is if one of these is 0. So you say 2x plus 1 can't be 0, or 3x plus 7 can't be 0. This one we already did. Right? I'm losing some of you guys up.
Yeah.
Shit. Some of you guys are like, that's all the math I could take today. All right. X can't be negative 7/3, and what do you get here?
Negative 1 and 1.
Negative 1/2. All right, just divide by 2 down there. All right, not too bad, right?
Be careful not to distribute. Right?
Yeah, that would be going backwards.
Okay.
Yeah, once you get it broken up, that's beautiful because now you can look at each piece. All right, that's the point of that. That's how you do that problem. Okay. So again, even that requires knowledge of factoring to do. Right? Almost everything in Chapter 7 needs that.
And I think for this one, if we use the FOIL, it's simpler. It's more simple to use that.
So other methods to factor this could involve trial and error, which I think is what you're referencing, right? Trial and error. You figure out what makes 6 and you figure out what makes 7?
Right.
Yes.
Yeah.
Cool. I won't teach that method, but you can use that method. It's
in
completely...
the book.
Yes, it's in the book.
Yeah.
Cool. I like it. The only one you can't use is the one that's called bottoms up, which is where you find these numbers and then you divide and the magic happens, right? You cannot use that one. It's kind of silly. The hard step is figuring out these numbers. It should be easy after that. Grouping should be relatively easy to do. Yeah. So it never really made sense to me. Okay. All right. So let's see. So let's focus on this just for a little bit, and then I'll let us out a little bit early. So help me out here. So far we've talked about how to multiply, how to reduce, how to multiply these things, how to divide these things, which is just really multiplication, the same thing, right? So those are the first couple sections. Now, of course, we're going to start talking about how to add, subtract them. And of course, if you have fractions and you want to add or subtract them, what do you need? Before you can add or subtract fractions, what must be true? Common denominator, right? Common denominator. So, for example, if I had 7/15 minus 1/15, why is that easy?
Because common denominator.
Because I already have a common denominator. So what do you get there?
6 over 2.
Are you done?
No.
Yeah, you can divide by,
Right, 3.
so it becomes,
2.
okay, good. So everything that just happened will definitely happen when I have variables on the bottom, because again, variables are just numbers that I don't know, so they have to act the same way. So if I had instead, if I had 7 over x minus 2, minus 1 over x minus 2,
6 over x minus 2.
I'll be careful. Can I go any further?
Factor out. No.
Can I?
No.
Nope, nothing's common. Let me ask you this weird question. Is there a 2 on the bottom? No, there isn't. There's not a 2 on the bottom, right? And that's where, another place where you guys think I'm insane. You go, Jeff, you're off your meds again. But if I had 6 over 5, is there a 2 on the bottom? Is there? It's a weird question. Is there a 2? It's not a trick question. Is there a 2 on the bottom? No. Even though I can write this as 7 minus 2. You understand what I mean? So is there a 2 on the bottom? No. What's on the bottom? X minus 2?
X minus 2 is a whole.
It is a number. If x was 7, this would be the number 5. Does 5 have a 2 in it? No. So see, that's why you can't do this, because that 2's not really even there. I don't know what this number is, so I can't do anything with parts of it, right? But if I had that whole x minus 2 up here also, whatever that number is, I don't care what, it would cancel. Thank God, right? All right, good. So let's try one like that. What if I had, what do you got, Jeff? So what if I had 3x over x plus 4 plus 12 over x plus 4. What do you get there? All right, so far these are pretty simple. The bottoms are the same. You're waiting for when the bottoms aren't the same. Bring it on.
3.
So it'll be 4x. No,
3. 3.
Yeah, we'll get there.
Oh.
You're right. It's perfect. But let's go there one step at a time. So what's the first step here?
3x plus
Yeah,
12.
so you can do 3x plus 12. Now, if I do this, what did I do wrong? Do you see where somebody would tell me that? Everybody realized it's wrong. What did somebody do?
You combine one.
Yeah, and of course that doesn't make it, I wouldn't put that over 30 or so, or over 0, even worse, right? Like I subtract the bottoms. The bottom just stays what it is. And what do you always have to do last on a fraction problem? You have to see if it reduces. And what can you take out of the top?
3x plus 4.
So then, 3. Now really think about what that means. Whatever x is, it makes this a fraction and that a fraction, and it will always come out to be 3, no matter what you make x. And what could you make x? Anything except
4.
negative 4. Somebody close the door for me. Thank you. Maybe when they set up camp right there. And the door has a vent in it, so we can only do so much. All right, you guys doing okay so far? All right, some of you guys are already looking at the clock.
Actually, I have a question.
Yes.
You always just combine two top numbers.
If the bottoms are the same, of course, right? And that's just like this. This was easy because the bottoms were already the same. All right. Now, let me show you something interesting. I can't remember if I showed you this already or not, but let's take a step back to when everything was numbers. Thank you. And investigate if the bottoms are not the same. So if I had 11 over 28 plus, what you got you? 3 over, let's say 18. That looks, oh, well, let's make the top 7. There you go. So you can't reduce it and escape it. That's gross. But let me show you something. And this helps with ugly denominators. But also, it's the only way that we can do when the bottom is variable expressions.
Can you just multiply this side by 28 and this side by 18?
Totally. But would that be the LCD? No. Because what do they share? What do these two share?
9. No.
You could use
2.
2! I like that. You're like, I just threw it out there, man. I mean, 9 doesn't go into 28. 3 doesn't go into 28.
4.
Right, so it's 2 times 14, and this is 2 times
9.
9. So see how 14 and 9, do they have anything in common? No. Now stay with me. So the way you could always do this, the way you could always do it if you wanted to, is you could figure out what's the biggest number they have in common and then factor both of them like that. Now why is that good? Because now I can see who's missing what. So the whole point of LCD is give each thing what it's missing so they both end up with the same. Right? So I always equated that to having kids. And you give your kids ice cream. If you have kids, if you have more than one kid. Is anybody in that situation? Anybody have more than one kid? If you don't have more than one kid, you might have been more than one kid to somebody else. And if you get ice cream, what's the first thing you do? I got more than me. Right? So I think about this. They're like, oh, he's got something that I don't. He's got something that I don't. So you're trying to make everybody happy. You give them what they don't have. So what has he not got that he's got? That's a weird way to say it, but what? Yeah, he needs a 9. So multiply top and bottom by 9. That's a bad color. Yeah. And that's a little bit better. He needs 14. So that makes it less of a guessing game. It makes it a nice, recipe-ish way to kind of get there. So whatever the hell 9 times 2 times 14 is, that's the LCD. What is 9 times 2 times 14?
252.
252? Okay. So then you got what? What do you have?
99 over 252.
Well, that's neat. I didn't do it on purpose. I wish I could say I did. Yeah, okay.
Well, you just combine everything.
197 over 252.
Yeah. Because what did we do? What we just multiply by 9. So what's the total thing I have on the bottom? 9 times 2 times 14. That's the number I have on the bottom now, right? So by doing that, you make the bottoms the same. Of course you'd make the bottoms the same number because you made sure they have the same pieces. So they have to be the same number, right?
That's like a shortcut thing.
That's like a nice way to organize it. Yeah. Or shortcut, whatever you call it. And then you get...
Yeah, 197 over
Beautiful.
252.
197 over 252. What do you think? Can you reduce that?
Nope.
I mean, that looks like it's prime, but you never know. At least do this one check. Remember, did I tell you this already? if you add the digits in a number like, what's 2 plus 5 plus 2?
9.
So it's divisible by 9. Did you know that? Have we talked about that? Any number, I don't care how big, small, whatever, if you add up the digits and it comes out to be a multiple of 9, the whole number is divisible by 9. It's a very interesting thing. And everybody used to know that. Something you used to always teach. And now people are getting lazy teaching. They say the calculators, screw you. That's something we should know. We should just know that. It's not your fault you don't know it if you don't know it. Nobody ever told you. But the top is 1 plus 9 plus 7 is 17. That's not a multiple of 9. So at least I know 9 or 3. None of that will go into them, right? All right, that's enough. All right.
And that's just for 9, right?
Yeah, just for 9. 4 is interesting. 4 will go into this number as long as the last 2 digits are divisible by 4. Any number. If the last 2 digits are divisible by 4, the whole damn thing is divisible by 4. And that's because 4 goes into 100. That's the reason why it works, but screw that. That's a nice way to remember. 7 doesn't have any rules, so don't ask me. Poor little 7 dude is just too weird. All right, so let's see what this looks like with variables in it, and then we'll head out. Nice and early, wow. So let's see if I had. So you're going to get used to this. A lot of chapter 7, the first step involves. What do you think? What was our first step here? We factored it, right? I feel like I was doing that thing from Kill Bill. All right, sorry. I can escape my cough. All right. So I can't add them. Is that obvious? Hopefully, right? Because they don't have the same bottom. But what is this if I factor it?
X 3 x 3 x minus 3.
So what do they both share?
X plus 3.
They both have an x plus 3. So what's the other dude need? Right? He's like, oh, he's got an x minus 3. Okay, here, be quiet. It's probably a good thing I don't have kids. So now they both have on the bottom this. So what do you get on the top? You get x plus.
X minus 9.
Now here's where you got to be really careful. There's many ways to mess this up. Could I cancel the x plus 3 that's there? Is that really an x plus 3 there? No, it's not. It's x plus 3x, right? So you can't, if you had to give this guy stuff just to be able to put them together, you have to simplify this before you can even think about canceling something out. If you can give it and then just cancel it out again, what the hell, why would you have to give stuff to it in the first place? So now it's cleanup step. What do you do on the top?
4x minus 9.
Yeah, and does that even factor?
No.
Do you lift, bro? No, I can't. It doesn't even factor, right? So look at me. It doesn't factor. So I stop there. I know nothing's going to cancel because I can't even factor the top. So I can't stress this enough. Chapter 7 is really easy if you know how to factor. If you don't know how to factor, it's impossible. All right. Enjoy your long weekend if you actually have Monday classes.